All right, today we're going to talk about a masterpiece of biomechanical engineering that you use literally every second of the day, your shoulder. And no, it's not just a simple ball and socket. It's an incredibly elegant system that powers every single move your arm makes.
I mean, just think about it for a second. Reaching up to a high shelf, throwing a ball, even just waving to a friend. All of that incredibly complex movement starts with two surprisingly simple bones. So let's dive in and meet them.
These are our unsung heroes right here. You've got the clavicle, you probably know it as the collarbone, acting as this rigid support strut. And then you have the scapula, or shoulder blade, which is this amazing mobile base. Together, they are the dynamic duo responsible for all that freedom of movement in your arm. Okay, first up is the clavicle. Its main job, its whole purpose, is to act like a strut. Like a supportive rod. It connects your arm to your torso, and its job is to hold your arm out and away from your body. This is absolutely essential for transmitting force from your arm through to the rest of your skeleton. The clavicle is a seriously weird bone. Unlike most of our other long bones, it lies horizontally. It's so close to the surface you can feel the whole thing right under your skin. It doesn't have a marrow cavity, which makes it incredibly strong for its size. And get this, it's the very first bone to start hardening when you're a fetus, but it's one of the last to fully fuse together, sometimes not until you're 25 years old.
So here's a cool little anatomy party trick. If you ever happen to find a clavicle, here's how you can tell which side of the body it's from. The end that connects out to your shoulder blade is flat. The end that connects to your sternum, your breastbone, is kind of blocky and large. The top surface is smooth, and that outer third has a forward curve to it. It's a very, very specific shape for a very specific job.
And that unique S-shape, that is definitely not an accident. The inner two-thirds of the bone bulge forward, while the outer third curves back. This double curve doesn't just give it strength, it also creates these crucial little tunnels for muscles, nerves, and blood vessels to pass right underneath, all safe and protected.
This bone is also a massive hub for muscles. I mean, just look at this. You've got powerful muscles like your pecs and your deltoids starting here, and your huge trapezius muscles inserting onto it. It is a critical anchor point for so many major muscles in your neck, chest, and shoulder.
All right, so that's our strut. Now let's move on to our second hero, the scapula. If the clavicle is the fixed strut holding everything in place, the scapula is the mobile platform. It's this flat, triangular bone that literally glides and rotates across your back, letting you position your arm in an almost infinite number of ways.
So here's the basic rundown. The shoulder blade, or scapula, sits on the back of your rib cage. Generally, its main body covers the area from your second rib down to your seventh. And its ability to just slide and glide over your chest wall is totally key to its function.
The scapula has two very different surfaces. The front surface, the one that faces your ribs, is concave. It's curved inward. This lets it glide super smoothly. But the back surface, the one you can actually feel on your back, is convex. It's curved outwards. And it's home to some really important structures.
The most obvious feature on the back of the scapula is this, the spine. It's that bony ridge you can feel running across your shoulder blade. It's not just a ridge, though. It actually divides the back of the bone into two hollows, or fossa, and these are where some of your key rotator cuff muscles live.
Now, if you follow that spine outwards towards your arm, it flattens out into a process called the acromion. A great way to think of the acromion is as the roof of your shoulder. And this spot right here, this is the exact point where it meets up with our first hero, the clavicle.
Okay, now let's look at the side of the scapula. Here we find the glenoid cavity. It's a very, very shallow socket, almost like a little dish. This is where the big round head of your humerus, your main arm bone, sits. Now, its shallowness is what allows for such an incredible range of motion, but it's also what makes the shoulder joint, well, pretty unstable. And finally, there's one more key feature you need to know about, the coracoid process. It's this hook-like projection that points forward. Honestly, it looks just like a bent finger. And this little hook serves as a super important attachment point for several muscles and, as we're about to see, some very, very important ligaments.
So, we have our strut and we have our platform, but how do they actually work together as one coordinated unit? Well, that's where the real magic happens. These two bones meet at the very top of your shoulder, at what's called the acromioclavicular joint, or AC joint for short. This is where that flat end of the clavicle connects with the scapula's acromion. It's a tiny joint, but its subtle gliding movements are absolutely crucial for lifting your arm over your head. But the thing that really lashes these two bones together is the powerful coricoclavicular ligament. Remember that coracoid process, that bony finger we just talked about? Well, this super strong ligament runs from there right up to the underside of the clavicle, anchoring it down and stopping it from popping up. It really is the main stabilizer for this whole system.
Now, this whole system is elegant for sure, but it's also vulnerable. So let's take a quick look at what happens when this carefully balanced mechanism gets compromised, and we'll start with our strut. Okay, here's a staggering fact for you. Despite how important it is, the clavicle is the single most commonly fractured bone in the entire human body. Think about it. It's the only bony link between your arm and your torso. That means it takes the full force of pretty much any impact to your shoulder.
And the break almost always happens in the exact same spot, right at the junction of those two curves, where the inner 2/3 meets the outer 1/3. That is its weakest point, and when it goes, the weight of your arm usually pulls the whole shoulder downwards and inwards.
The scapula's position, on the other hand, depends entirely on muscle balance. And this is what happens when those muscles fail. If the trapezius muscle gets paralyzed, the shoulder just droops. If the serratus anterior muscle fails, the scapula pulls away from the ribs, creating what's known as a winged scapula. It's a very clear visual sign that the platform is no longer secure.
So, let's bring it all back together. What do we have? We have a rigid strut, the clavicle, holding the shoulder out from the body, and we have a mobile platform, the scapula, that glides and rotates. The combination of these two simple designs is what creates that unparalleled, amazing range of motion in the human shoulder.
It really makes you think, doesn't it? The body's ability to achieve such complex function from these really elegant, simple components is just remarkable. It kind of leaves you wondering, what other simple designs are hiding in our anatomy, creating these extraordinary results for us every single day?